All right, I'm ready to get to it. Are you? Let's take a look at the distance formula, but before we do, let's check out some prerequisite knowledge. And I'm going to go through this pretty quickly because the expectation is you already know how to do this. Let's simplify the radical square root of 72. There are two methods to choose from. Either one works. You pick which one is your bread and butter. All right, square root of 72. I'm going to call that the square root of 36 times 2. I'm breaking it up into the biggest perfect square that goes into it, which is 36. Square root of 36 is 6, and I'm left with the square root of 2. Beautiful. But what if you don't know how to do that? What if you don't know 36 is the biggest square that goes into 72? Then you're forced to do a factor tree. Break it up. Here we go. 9 and 8, 3 and 3, 2 and 4, and 4 is 2 and 2. And I'm looking for groups of 2 because there's an imaginary index of 2 there. So there's my 2 3s. Here's my 2 2s. I take the 3, I take the 2, that makes a 6. And this lonely 2 has to stay home alone, no one to play with. Either way, I don't care which way you do it. Choose whichever method works for you. We're going to apply that to the distance formula now. The distance between the 2 points A with coordinates x1, y1 and B with coordinates x2, y2 is as follows. The square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Well, that certainly has a lot of jargon in it, and I don't want you to get mixed up. So let's just really focus on what this is. Now, I like to use colors to help me here, so I'm going to show you where everything comes from and how do we end up plugging it in. So I'm just highlighting things right now to keep my mind straight, and that might help some of you who are more visual. So if you know you're a visual learner, you might want to take out the highlighters right now. So I've got this going on. All you want to notice here is that we're plugging and chugging. You're going to take coordinates and shove them into this formula and figure out what it turns out to be using the order of operations. So all I'm going to do is use this to help me find the distance between the points 1, 5 and 2, negative 2. Now, because we're just starting this, I'm going to encourage that we take the time right now to label our points as x1, y1 and x2, y2. So I'm going to call my first point x1, y1 and my second point x2, y2. Just like that. Isn't that nice? All right. And it might seem like a baby step to take, but to tell you the truth, a lot of people get mixed up, and it's very easy if you try to rush through these problems to make mistakes. So let's plug and chug here. Let's plug them into the distance formula. Now I'll tell you what, I kind of like to cheat. I already set up the formula even before I put the coordinates in. I always just do the square root. I set up my parentheses and my squares with the big plus sign in the middle, and I know that the minus signs go in between. And now I got to plug and chug. So let's do our highlighting to help me out here again. All right, I want to find my x1, my y1, my x2, my y2, etc., etc. So I know here's my x1, which always goes in this spot. I've got my y1 right here, and that ends up in this spot. I've got my x2, which is 2, and that's going to end up all the way over here. And then lastly, I've got my y2, which is negative 2, and I'm going to put it right in here. So here we go. Time to plug and chug. So x2 minus x1, well, my x2 coordinate, all that x2 really means, and let's really break that down, is it means it's the x coordinate of the second point. That's what it means, that little subscript. Don't let that freak you out or anything, okay? x2 just means the x coordinate of the second point. So that's a 2. Minus x1, which is the x coordinate of the first point, which is 1, plus y2, the y coordinate of the second point, which is negative 2, minus y1, which is the y coordinate of the first point, which is 5. And now it's plug and chug time, ladies. Let's get to it. Here we go. Order of operations. That is what is key here, okay? PEMDAS. We got to do our parentheses first. You do not want to distribute that squared. Do not do that. Whatever you do, no, 100 times no. No. Here we go. We're going to work inside our parentheses. 2 minus 1 is 1. Negative 2 minus 5 is negative 7. You want to be careful with your addition and subtraction here. And I get 1 squared, which is 1, plus negative 7 squared, which is positive 49. Don't tell me negative 49, okay? Negative 7 times negative 7 is positive 49. You will never, ever have a negative under your square root sign in the distance formula. You got me? So if you do, go back, check it out. What did you do wrong? 1 plus 49 is 50, and I'm going to choose method 1 as my bread and butter here. I get 25 and 2, which gives me a final answer of 5 square root 2, meaning the distance between the point 1, 5 and 2, negative 2 just turns out to be 5 square root 2. Well, we have another formula on our hands. It's the midpoint formula, and believe it or not, yes, you must memorize it. So go ahead and study that. Now the midpoint, pretty easy if you think about it. Mid meaning the middle of 2 points. So we need to find the thing that's smack dab in the middle of 2 points. We're going to use this formula, x1 plus x2 all over 2, comma, y1 plus y2 all over 2. Now notice there's a comma. That's because when you're finding the midpoint, you're finding a point. And yes, a point is always an x and a y coordinate. So we're really doing 2 short calculations here, the average of your x coordinates and the average of your y. So we're going to find the midpoint in example 1 of the segment joining 2, negative 9, and 6, 2. I drew a visual here. You really don't need to draw it. I'm just showing it to you so you believe me when we get our final answer. So let's go ahead and let's find the midpoint. Once again, because we're beginning here, I really suggest we label this as x1, y1 and x2, y2. And now all we have to do is plug and chug. Now I like to set it up just like I do with my distance formula. I kind of cheat. And it's not cheating. It's just setting it up. I always know that this is our setup. Now I just got to plug and chug. My x's, my y's, etc., etc. All right, so in place of x1, I have 2. In place of x2, I have 6. In place of y1, I have negative 9. And in place of y2, I have 2. And now it's just some calculating here. 2 plus 6 makes 8 over 2. Negative 9 plus 2 makes negative 7 over 2. And we're going to simplify when possible. And I get an answer of 4 negative 7 halves. Or you could say 4 negative 3.5. I'm okay with either. Let's check out to see if that makes sense. 4 negative 3.5. Well, on my graph, 1, 2, 3, 4. Negative 3.5, 1, 2, 3, and wow, I was really on top of it when I randomly drew that x. And it should make sense. Your answer should not end up somewhere over here or over here. It's got to be in the middle. You knew it was coming. Find the midpoint of 4, negative 6, and 5, negative 10. Hit the pause key, come back and check. I will accept 9 halves, negative 8, or 4.5, negative 8.
In order to graph a circle, we need to first be able to pick out the center of that circle and the radius of that circle. In order to do this, we're always going to want to rely on our equation of a circle. The equation of a circle with center h, k and radius r is as follows. We have x minus h quantity squared plus y minus k quantity squared equals r squared. First thing I want to make sure that you guys definitely do is take a moment to write down this equation. This equation is going to become the most important thing we are going to work with when dealing with circles. You definitely want to make sure you have this written down in your notes. Now that you've taken a minute or two to look at the equation, what I want you guys to do is pause for a second and think to yourself, why does this equation look familiar? The reason that you should have came up with is this is very similar to the distance formula. If you look at our definition of a circle, so let's take a look at this picture right here to help us understand this definition. What we know is we have a center, HK. So here's our point right here, our center of the circle, H, K. We already know that the radius goes from the center of the circle to any point on the circle. So here's our radius R. It's going to this point on the circle right here. What we should also know is that all points on the circle are going to be equidistant from the center. That's something that you guys should remember back from geometry. With that being said, what we know is that the distance from the center to any point on the circle is going to be the same. It's going to be our radius. This is going to play in to how this equation relates to the distance formula. It's because we are talking about a distance. If you take a look at our second picture over here, this should look familiar to you guys as well. We dealt with this in our Play-Doh lab. What we know is this was when we were talking about the double cone. It was sliced parallel to the base, and what it formed was it formed a two-dimensional cross-section that was our circle. Okay, so now that we've talked a little bit about this idea of the circle, let's jump right in and let's try one out on our own. What we want to do is we want to first identify the center and the radius of the circle given in this equation below. Then we're going to want to make sure that we go through and graph it as well. Before we even want to start thinking about the center and the radius, what I want to make sure we get in the habit of doing is writing down that equation of a circle in standard form. If you look back in your notes, or if you have it memorized already, it is the quantity x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. This is going to become so important to us. So if we go ahead and take a look at our first example, what we notice is that our first example is already written in standard form. It looks pretty familiar to this equation that we just wrote down. The first thing that we want to be able to pick out is we want to be able to identify our center. What we recall is it says our center was always of the form h comma k. What that means is what we're going to do is we're going to take the value that is inside parentheses and we're going to need to take the opposite in order to identify our x coordinate. So if we take a look, we have x minus 2 quantity squared. What that's telling me is my number in parentheses is a negative 2. For my center, we need the opposite of negative 2. So my x value is going to be a positive 2. From here, we know that we need to go ahead and do the same thing for our y. We have y plus 3 quantity squared. What we have to do is we have to take the opposite of that y value. Well, the y value that we have in parentheses is a positive 3. In order to take the opposite, that means the y value of my center is going to end up being a negative 3. Now we're already a third of the way there. We've identified the center. Remember though, we also need to be able to identify the radius before we can go to graphing. What we should look at is we should look to the end of our formula. What we have here is we have the number 4. Well, if you look in our generic form, a standard form of this equation of the circle, we know that that number is going to be equal to r squared. So what I want to do is I want to make sure we go ahead and set up a little equation. 4 is equal to r squared. We want just r. We want just the radius, not the radius squared. So in order to find that, we have to start by getting r by itself. What you guys should recall, in order to get r by itself, we need to take the square root of both sides. In this case, we know that our radius is going to be equal to 2 because the square root of 4 is 2. Now from here, what we want to do is we want to make sure that we go ahead and graph. We want to make sure we always start by graphing the center. Make sure you take your time. Our x value is a positive 2. My y value is a negative 3. So we want to start by plotting that center point. From there, what we want to do is we want to go ahead and we want to take a look at our radius. The radius is going to tell us the distance that we want to move. In order to form our full circle, we're going to use 4 points. That's going to be the rule that we pretty much are always going to follow. What this means is I'm going to need to plot a point up from the center, a point down from the center, a point left from the center, and you guessed it, a point right from the center. So let's go ahead and do that. When we go and plot these points, we need to use this radius in order to get the following points. So I want to go up 2 from my center. I want to go down 2 from my center. I want to go right 2 from my center. And lastly, I want to go left 2 from my center. In order to get the final picture of the graph, what we want to do is make sure we carefully connect those dots. Remember, we like a circle to be nice and smooth, so try and do this as best you can. Once you connect those, our graph of this circle should look like this. What we notice is we have now found the center and the radius, which has allowed us to make a beautiful graph of this particular circle. All right, let's try another example. What we want to make sure that we always start with, we need to get this into standard form. So remember, standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. Make sure you have this memorized. If you don't now, you will by the end, I promise. Now what we have to do is what you should notice is this looks a little different than the last example. What we have is we have this 8 hanging out in front. We cannot have any coefficients in front in order to have our equation in standard form. So to get rid of that 8, we need to divide all pieces by 8. On the left-hand side, I am now left with x minus 3 quantity squared plus y minus 1 quantity squared equals 352 divided by 8 is 44. Now what you should notice is this looks exactly like we need it to. It is in standard form. So we want to go ahead and start by finding the center. Remember, to find the center, we have to take the opposite of both our x and our y value. So in this case, my x value here was a -3. So my x value for my center is going to be a +3. My y value here was a -1. So my y value for my center is going to be a +1. Next, we want to make sure we go ahead and we find the radius. Well, we know that 44, that's giving me the value for r squared. So I'm going to set up my equation. R squared has to equal 44. Once again, in order to find our radius, we have to go and take the square root of both sides. So we get r equals the square root of 44. But we know that we can go ahead and break down the square root of 44. Remember, we never leave those radicals unsimplified. So I can rewrite this as 4 times 11, or you can make a factor tree either way, which is going to give me 2 root 11 as my radius. So now we just have to go ahead and graph. Remember, we start at the center, so I want to make sure I start at the point 3, 1. Always start at that center. And now we use our radius to get our other points. However, 2 root 11, how do I know which distance to move? Well, we have to get an approximation. When you put this in your calculator, this is approximately 6.63. So when we go and we plot our other points on the circle, we just want to make sure that we're going about 6.63. So we want to make sure that we go up 6.63. We want to make sure we go down about 6.63. We want to make sure we go right about 6.63. And we want to make sure we go left about 6.63. Remember, connect your dots. We want a nice smooth circle. And there we go. We did a nice job. Okay, and you guessed it. It's that time. We need to go ahead and take care of a you try. I want you guys to identify the center and the radius of the circle. Make sure you graph it as well. Take a minute to pause and work this one out. What you should have done was your center, you should have ended up with the point 0.4. Your radius, you should have ended up with 5. When you came over here to graph, your circle should have looked like this, and your center should have been at that point 0.4, and then you should have gone 5 to the right, 5 to the left, 5 up, and 5 down. Hope you did great. Okay, so now that you guys have become great at finding the center and the radius of a circle when you're given the equation in standard form, we need to talk about, well, what happens when that equation isn't in standard form? Well, what happens is we need to figure out a way in order to get it into standard form. In order to do this, we are going to have to rely on some prerequisite knowledge. This should look very familiar to you, especially since we just did a warm-up with it. Remember completing the square. In the past, we used this with solving equations. Remember, we take our b value, divide it by 2, and then we take that quantity and square it. By doing so, we are able to come up with a perfect square binomial. We have x plus that b divided by 2 quantity squared. Like I said, it helped us solve equations before, but now it's going to help us find the center of a circle. And guess what? We love finding the centers of circles. So let's start. What we have in our first example is we have x squared plus y squared plus 14x minus 12y plus 4 equals 0. Before we can even get the equation in standard form, let's write out what the equation of a circle is in standard form to begin with. We know it's x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. Told you guys are going to have that memorized by the end of this video. Now that we have that, what we should look at is, we have a whole lot going on here. But what we realize is we always want to have our equation equal to a number because we need that radius. So what we're going to do is we're going to start by moving over the only piece where we just have a number, no variable with it. So I'm going to go ahead and start by subtracting 4 from both sides. On the left-hand side, I am left with all of this now. However, I always like things to be in the correct order, and so do you guys, in order to complete the square. So I'm going to rewrite this. We have x squared plus 14x plus y squared minus 12y equals now negative 4. All I did was rewrite that. I put the x's with the x's, the y's with the y's. From here, now what we want to do is we want to go ahead and complete the square. In this case, we're going to have to make sure we complete the square twice. We're going to have to complete the square for my x's and complete the square for my y's. So I'm going to start by rewriting. I have x squared plus 14x plus, just like we did before, I'm going to go ahead and leave a blank. I don't know what that value is yet. Plus y squared minus 12y plus whatever my value ends up being equals negative 4. But don't forget, whatever I do to the left, I'm going to have to do to the right. So I'm going to leave room for both of my new values. Now what we want to do is we want to make sure we go ahead and we figure out, okay, what is that new value going to be? We keep saying new value, what is it? Well, what we want to do is we want to take our b value, which is 14. We need to go ahead and divide that value by 2. So when we do 14 divided by 2, we get 7. But then remember, we have to square it. So you guys should have gotten 49. So we put 49 on the left. We have to put 49 on the right. Now we got to go ahead and do the same thing for y. So in this case, my y value, what I have is I have negative 12 for b. I need to take that negative 12 divided by 2 to give me a negative 6, and then square that whole thing. So now I end up with positive 36. Whatever I do to the left, I have to do to the right. Now at this point, we can go straight to writing our perfect square binomials. What we know is we have x squared plus 14x plus 49. Well, remember, this always simplifies to just x plus that b divided by 2 value, which in this case was 7, quantity squared. Plus, we have to do the same thing with our y, so we have y minus 6, quantity squared, equals, don't forget on the right-hand side, we have to tally all of that up, and in this case, we get 81. From here, what you should realize is that this is in standard form. We can go ahead and square or box or circle, whatever you prefer, our final answer. We have found the equation of this circle in standard form. And as you can see, if we had to, we could easily pick out the center and the radius. Okay, you guessed it, it's time for another You Try. This time now, you guys are on your own. Write the equation of the circle in standard form. 8x plus x squared minus 2y equals 64 minus y squared. Go ahead and pause, take a couple minutes to figure this one out. You should have ended up with x plus 4, quantity squared, plus y minus 1, quantity squared, equals 81. If you didn't, don't worry, we'll discuss it in class tomorrow. Just be sure to make note of any questions you may have. The next piece that we're going to talk about is we are going to talk about writing equations of circles using a center and a radius. So this time it's going to be a little bit opposite. What we're going to have is we are going to have the center and the radius given to us. We now have to come up with the equation. So what do we need to start doing? You guessed it, let's write our standard form out. It is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. You guys better have that down. Don't forget it's important. Now let's take a look at our first example. What you should notice is right away we are given the center. We have a center of -1, 5. If you recall, when we have an equation of a circle in standard form, when we're picking out the center, we always use the opposite for both h and k. So this means we're going to want to do the same thing when it comes to writing our equation. What we know, every equation of a circle in standard form is going to have a parenthesis with an x. That whole quantity will be squared. Plus, the same goes for y. We're going to have a y plus or minus something and that quantity squared. It's our job to go ahead and fill in what goes where. Well, if you look, my x value here is -1. But remember, we want the opposite. So instead of x minus 1, I'm going to have x plus 1. Same goes for y. My y value is a +5. Well, instead of having y plus 5, I'm going to want y minus 5. Lastly, they give us our radius. Our radius, they tell us, okay, it's 14. But remember, in our standard form, we want the radius squared. So we're going to just fill in 14 squared. Now to get that full equation in standard form, we need to simplify that radius squared. So my equation will be x plus 1, quantity squared, plus y minus 5, quantity squared, equals 14 squared, which is 196. This is my answer. Let's take a look at another example. What we have is we now have the center 4, 0. What you should always start by doing is I would always just start by writing out, we know we're going to have an x plus or minus something squared, plus a y plus or minus something squared, equals my radius squared. So I'm just going to leave that blank. Now let's start by going ahead and filling in our opposite values. My x value of the center is a +4. Don't forget, I want the opposite, so I'm going to fill in x minus 4. My y value, when we look at this now, my y value is 0, okay? So we haven't really had to deal with that yet. But what we're going to do is we're just going to go ahead and add 0. It doesn't really matter with the sign because we know in the end it's going to end up dropping out. Lastly, that's got to equal my radius squared. So my radius is 2√5. So I need this to equal 2√5, that whole thing, squared. Well, we know that 2 root 5 squared, we're going to have to go through and find out, okay, what is that value? So this is just like saying 2 root 5 times 2 root 5. Remember, when it comes to multiplying radicals, what we want to do is we want to make sure we multiply those numbers on the outside. So in this case, 2 times 2 gives me 4, times, and the numbers underneath we multiply and keep underneath the radical. Root 5 times root 5 gives me root 25. We know, though, that the square root of 25 is 5, but don't forget we have to multiply that by this 4 out in front. So my r squared value gives me 20. So when it comes down to my final equation for example 2 in standard form, we have x minus 4, quantity squared, plus, since we just have a 0 here, we don't even need to worry about writing that. So we're just going to write plus y squared equals r squared, which we have just calculated to be 20. Okay, and we've made it to our wrap up. The main 3 things that we want to take away from today is the standard equation of a circle lets us easily find both the center and the radius. We definitely want to make sure we have that down. Next, when equations are not in standard form, what we have to do is go ahead and complete the square. Don't forget that skill. And lastly, the center and the radius are the only 2 things we need in order to go ahead and write the equation of the circle. I hope you guys have enjoyed your first video on circles, and I can't wait to talk more about them tomorrow.